on yesterday, number 7, I believe. I'm gonna go back to look at it right now. Sorry.
It's okay.
Yeah, so number 7, when we went through that yesterday, I was putting in the decimal places because it says round to 4 decimal places. And then for some reason, I got them both wrong. And I kept trying to like round and stuff, and it was rounded very weirdly. And I honestly don't even know like how they got those answers. And so I tried another similar question. And then it did the exact same thing. So I don't know what to put.
That's weird.
For the answers.
And discouraging. Well, let's look at it. You mind if I copy it up that problem?
No, not at all.
Okay. Okay, so population value has a normal distribution given and a standard deviation given. You intend to draw a sample size of 164, so that sample size is going to be important for us. Find the probability that a single selected value is greater than 206.7. Okay, so that 206.7 is very close to that, right? So we'd expect it to be, somewhere near 50%. So the fact that your answer is fairly near 50% seems reasonable. It is a little bit above, so we expect it to be above. This standard deviation is also quite small, but not really in comparison to the 0.3, right? The difference between these is only 0.3. So that's well less than one standard deviation. It's a 1/10 of a standard deviation. So I'd expect this to be really close to 50%. Frankly, even a little bit closer to 50%. Ooh, but they're being mean here. Oh, that's dangerous. Okay. So that's just some initial observations. The fact that this is really, really close and that this is very small difference in comparison to that standard deviation says this should be super close to 50%. Does that part seem reasonable?
Yes.
All right. Now, I have always suggested drawing these out, right? So I'm going to follow my own advice, draw it out. We have a mean at 206.4, and we have a standard deviation of that 3.9. Now, this is talking about a single randomly selected value, right? So the question is, first off, is this in the population distribution? Is this in one of the samples? Is this one of the data distributions for a particularly gathered sample? Or is this question occurring in the sampling distribution? Well, this is a single random selected value. So a single value exists in really either the population distribution or the data distribution. It doesn't really matter, they're the same. Well, they express the same thing. So this question is happening up in the single values world, where we're looking at one particular value. That's the population distribution or the individual data distributions. So essentially that makes this first question a Chapter 7 question. Fair?
I probably missed it.
Yes, thanks.
What's that?
I probably missed it in chapter 7, so now I'm having trouble.
Well, what did we do in chapter 7? In chapter 7, when we were asked, we were given means and standard deviations, right? And asked what's the probability of being within a certain range. So we went to that
Right.
value, the 206.7. The 206.7 there. I'm again probably drawing it a little far away in my scale, but man, that 207 or 206.7 is awfully close, right?
Yeah.
And then I'm going to shade the region that we want, right? Which region do we want? Do we want the region above 2067 or below 2067?
Above.
We want above. And Tessa, it looks like you were doing below.
Oh,
Fair?
yeah.
And it looked like you were doing below in the sampling distribution. But we got to be careful about that above here.
So is it the inverse?
Well, let me
function?
get there. Let me get there.
Okay.
I know it's exciting. We want to hurry.
I know.
So we're going to need to do the whole 1 minus thing at some point, right?
Yeah.
Because our tools, we know, deal with a lower section, not so much with an upper section. It depends on what tools we use, though. But have we been given the proportion and we're asked for values, or have we been given the values and are asked for a proportion?
Portion and ask for the values.
What proportion have we been told? If you can't find it, then we probably weren't told the
Weren't given it.
we weren't given one, right? We're asked to find one, right?
Oh,
So that's the direction this question's going. We were given the value, 206.7. We're being asked for the percentage, the proportion, the area. Fair? So we want to find this area. Kim, is that fair?
yeah.
Okay. So that's not our inverse tool. That's our norm dist tool.
Okay.
And if we did our normal distribution tool, if we did our tables, or we used the way the calculator is naturally set up, we'd be doing this lower portion, right? So I would tend to do 1 minus that at 206.7.
Is that the PDF or the CDF?
For norm distribution, it's always C.
Okay.
So if I grab my calculator here, I'm going to go to normal CDF. We could change this lower to the 206.7 and the upper to 1e to the 99th if you wanted to, and just not have to do the 1 minus.
Right.
But that's just not my habit. Either way would be fine. 206.7 with a 206.4 mean. And this is just, again, our normal standard deviation here, because it's a single value we're looking at. So it's just that 3.9.
Okay.
But I want to subtract that from 1. So I'm going to get that answer and go 1 minus that answer. So it certainly looks like this 5306 that you were getting tested, that's the other portion that you were doing the less than, which is very natural. You have to notice this greater than or less than symbol to know it's the other way. Does that make sense? Or,
Yeah.
Tessa, does that make sense? Yeah. Okay. So the 46.9, so I'm just going to say 47. Well, they wanted it rounded how much? 4 decimal places. So 4693. 4693. 0.4693. Now, again, that's for a single value selected. But if you're selecting samples of size 164, where samples of size 164 are going to have a much tighter, more tightly distributed sample of means. So instead of asking what's the chance that a single value would be greater than 206.7, what's the probability that we would find an average that's above that? And I often use the example of height. I've talked about height before. You know, the chance of finding somebody who's over 6 feet tall in a classroom, well, that's pretty easy. You know, there's not going to be a lot of them, but you know, the chance that there's somebody who's over 6 feet tall in a classroom is pretty high. What's the chance that the average height of everybody in the classroom is over 6 feet? That's really low. And that's really the difference that we're looking at here. Are we looking at the probability of individual values, or are we looking at the probability of averages of a particular size? And what we're looking at here in the second part of this question, in the sampling distribution, is what is the distribution of those averages? Now, what do we know about the distribution of those averages? Well, we know the distribution of those averages is much tighter. Oop, God, that was terrible. Sorry about that. It's still going to be centered around our 206.4 because that's the true average. So the average of our averages should be our average. But it's going to be much tighter in its distribution. So we're going to switch from our standard deviation to that standard error by taking our 3.9, our standard deviation, and dividing by the square root of that sample size, 164. So what is 3.9 divided by divided by the square root of 164?
Point 3045.
0.3045. So very small by comparison, less than 1/10 of the value. So our averages, our data was really tightly distributed, but our sampling distribution is even more tightly distributed. So here, the chances of being more than 206.7, okay, the chances of being more than that 206.7, well, it's going to be about half of our data. The chances of our average being more than that, it should be less because we have less variance in our averages. But we're going to do the same thing. 1 minus the norm just at the 206.7. The only difference is that's the standard deviation we're going to use. So we're going to go back to that distribution tool. Same question, same setup, except it's in the sampling distribution. So we use the tiny 0.3045. Again, I'm going to get that answer. And again, Tessa, that's the answer you have here, but that's for the lower section. 1 minus that answer That's the upper section. Latessa, it sounds like you were handling that problem really well, just missed the whole it wants above instead of below.
Mhm. Okay.
And yeah, again, notice those are very, very different, even though it's the same points. Again, it's because of that tightness in the sampling distribution. So Tessa, it sounds like you spent quite a while fighting with the rounding and approximations as an issue when that wasn't the issue. I'm sorry. That can be frustrating.
Can you go back to the calculator real quick and show me how you put that in?
Sure. So I went to and there are options with how to put it in, but I went to the normal EDF. So the normal cumulative distribution function. We never use that PDF for normal distributions. And by default, it does the lower bound of, negative everything to the upper bound. And we could change that, but I don't like to. It's just because I'm so used to the and down tools. So we want to go all the way from everything down all the way up to the 2067, so the 206.7. And then our mu, our center, is at the 206.4. And for this second problem, that standard deviation, well, it is a standard deviation, but it's our standard error because it's a sampling distribution of the 0.3045. And then pasting that in. Now, your calculator might not have this submenu, does it? Some of them don't.
No, it doesn't. It just has the parentheses where you type it in.
Yeah, and that's a slightly older model, which is unfortunate. But it's still, so you have to type in the -1. And that, let me actually force it to do that, because it is, there was a way to force it to do that. Well, if I do that, I can force it to appear that way. Yeah, people got really frustrated with that on calculators, so eventually they started putting in those little sub menus because it's irritating to not, like, okay, give me parentheses, but I don't know the order it wants.
Yeah.
But the normal does go from low, so that -1, and you'll notice right above the 7, there's that comma, and above that comma it says EE. So that second EE automatically puts in that times 10 to what power. So that gives you that scientific notation automatically. You can just type times 10 to the 99th power if you want to, but that's where that EE button, that's what it does, to give you that really quick, that is negative infinity. Out to 206.4, where, and these are good commas, where our mean was the 206 point, oops, we don't go out to 206.4. We want to go from negative infinity to 2.607. These numbers are too close together. where our average was 206.4, comma, and if we're doing standard error, then the standard error was, what was it, 0.30, I forgot, 45?
Yeah.
45, end parenthesis. And that's going to naturally give us the lower section, except I didn't type it in right. See, it's hard to do that way. That's why people complained. Oh, I used a subtraction, not a negative.
Yeah.
And then that's the lower portion, 1 minus that, 1 minus, and I'm going to go second answer to bring up that last answer so I don't have to type all that stuff in. And actually, not only does this second answer automatically use these 9 or 10 decimals, it actually uses 27 decimals of accuracy that the calculator holds in the background. So calling answers is always advantageous.
I keep getting the answer 1 on my calculator instead of the 377.
Ooh. What are you
Yeah, I
typing?
was getting that. I was getting that too. And that's why you got to make sure all four pieces of that information are in there. I was getting that when I put only like the first 3 pieces or something, you know?
Oh, if you leave off the
Yeah.
the first part, especially.
Yeah. If you leave one of those out, you'll get 1.
So yeah, the key really is that we're looking at the normal. This is the CDF, and it's low, high, mean, standard deviation.
Mm-hmm.
And that could be mu and sigma if we're talking about a population. So what were you using before to get those of values? Were you using Excel?
No, I was using the calculator, but what we went over yesterday, I was like doing it along as you were doing it as well.
Right.
And I got the same answers as you did. Like I understood how to do it. I think it just we didn't do the 1 minus normal distribution thing.
Right.
Yeah.
And yeah, it's, and we might have missed it yesterday, but yeah, that's the greater than and the greater than. So, and that is an easy thing to overlook. We're so used to these tools talking downward. And it's really easy to read through a problem and miss that it's saying, nope, upper, nope, upper.
Mm-hmm.
So that is something to be careful of. So, Andrea, did you find where it was being weird?
No, it's still giving me the same answer again.
Wish I could grab your calculator. If it was a class, I'd grab your calculator. And
Right? I know, like, I want to show you. I don't know if you could even like see it on there. It's probably backwards. And then, so I have it all in order. I'm not sure if you can see it. If you like double check my inputs.
Yep, I can see it.
Okay, and let me click enter. And I click enter.
It drops down 1. Yeah.
Go down. All right. So then I'll click enter. And then
that's why.
oh,
Go back to those values.
okay. Okay.
You have the standard error as 0.03.
0.03 instead of the
0.3045.
oh 30. Oh geez. Okay.
Had to be something, right?
I'm like, what the heck is happening
Yeah.
over here? User error.
So one of you were asking about that, what this distinction is and why it's important or significant. Is this discussion and the one before helping with that? I want to make sure that you're happier with that.
Yes.
Okay. Well, we could try this. Given a normally distributed population of values with a mu of 47 and a standard deviation of, I don't know why I switched to of instead of equals, but that's okay, of, let's go with 13. What is the probability that the average of a 10 value sample will fall? Ooh, let's make this horrible, right?
Oh, yeah.
Fall
Oh,
outside the range. Oh, what do I want here? Of 45 to, let's say 50. Okay, before I have you try to answer that, well, I want us to kind of look at it and think about what we've got. Hold on. Cord came out. So we've got an average of 47. So 47 is not centered in there, but 47 is, in near the middle of that range. When we got a standard deviation of 13, so a standard deviation of 13, that's, pretty wide. And this 45 to 50 is comparatively tight. So it might seem reasonable that we're going to get a lot of things outside that range. Fair? But we're not asked for the probability that a particular value is outside that range. We're asked for the probability that an average is outside that range. As soon as we're talking about where averages are we in our population distribution or are we in our sampling distribution?
Sampling.
Yeah, we're in our sampling distribution. So when we draw our, as I know you're drawing these.
Yeah.
When you draw your distribution, we know our distribution is normal. Even though the sample size is very small, how do I still know that our sampling distribution is normal?
They asked that.
Usually to be normal, our sample size has to be at least 30. How do we know in this case that our sampling distribution is normal, even though the sample size is only 10?
Because they tell us
Nope.
it's normal. Oh,
What do they tell us is normal?
The normal distribution population of values.
Population is normal.
population.
If the population is normal, the sampling distribution is always normal.
Normal, yeah.
Okay.
So you're sort of right, Kim. They
Yeah,
do
okay.
tell us,
You see.
but they tell us the sampling distribution is normal by telling us the population is normal.
Okay.
If the population wasn't normal, or we didn't know whether it was normal or not, we would need that sample size to be at least 30.
Okay.
The mean of our data should be equal to the mean in our sampling distribution, because it always is.
Mhm.
So that's still going to be 47. But when we look at our standard deviation in our sampling distribution, which we call standard error, it's not going to be the 13. It's going to be something else.
Is
So I'm going to give you a minute to kind of finish this question off, figure out what you have to do to get your new standard deviation, and how you're going to answer what's within that range.
3.
So I'll give you a minute to play with that.
So
We're just trying to find the standard deviation, right? You said?
Well, and try to figure out what's the
Range.
final probability within that range.
Oh, okay.
But your standard deviation for your sampling distribution, or in this case, the standard error,
Mm-hmm.
should end up being that of 4.11.
yeah.
Yeah.
So what's the answer to this question?
I don't know if I did it right. Oh, wait to see.
What'd you get?
Why did you? Okay, see, I thought you had to do it as like two different problems.
If you're doing it with the Z-score table
Yeah,
or with Excel, you do
Yeah.
have to, because they only give you and down, right?
oh,
But the calculator, the one big advantage the calculator has is that normal CDF tool, you can change that low value
okay.
and just do it as one. Now, if you did it as the, -1E99
Uh-huh.
for both of them and then subtracted it, you should get that same value. Should still totally work.
Well, what I tried to do was the first do CDF for 45 down,
Uh-huh.
and then do CDF for the -1 to 99.
Uh-huh.
I mean, then do the minus the CDF for the 50. But
That would have
didn't
given
work.
you the -0.45 because you're subtracting them backwards.
Ah,
Is that fair?
okay. I see.
You'd have gotten the same value, you just would have had the different sign.
Okay.
So yes,
Okay.
you could do, and if you were doing Excel, you'd have to do the norm dot dis with the 50 minus the norm dot dist with the 45.
Okay, that, yeah,
But that order, if you switch the order, you make a negative sign.
yeah.
So should give you the same thing. But again, so what does that mean the answer to this question is? What is the probability that's asked for here?
It's not the 45/40?
That's what I'm asking.
Is it the opposite of that? Because we want it outside that?
Are you asking me that, or are you telling me?
I'm asking you that.
The probability of being outside, you're absolutely right, outside the range. This is the probability of being inside that range, right?
Inside, right.
Probability of being outside that range, 0.5460, or 54%.
Ah,
Must read the problems, right? Very carefully.
Yes, we must.
Oh, that's cool, because I did get it the way I did it.
Mhm. Well, for
It
you,
just
that
was
negative is
way
handy.
longer.
Yeah.
And
Well, and that's actually not an unreasonable habit, because again, if you're using the tables, you have to do it that way. If you're using Excel, you have to do it that way. The calculator is a fairly specific tool. It allows you to avoid all that. So I think it's a perfectly reasonable habit. All right, questions about it? Any of that? This stuff does take a little bit of practice. You can very much tell that reading the problems carefully is really important. Be sure you're asking yourselves those questions. Am I in the population distribution? Am I talking about single values? Or am I in the sampling distribution? Am I talking about average results? Fair? So
So I had
careful.
another question, Matt. Is there a way to see our last tests, the ones that we missed, so we can?
Yeah, you should be able to go in right now and it'll show you if you go to a gradebook and then
Yeah.
click on it, it should not only show you what's wrong, but show you the
Oh,
correct answer.
awesome. Okay, great. Thank you.
Sure. Okay. Anything else I can do for any of you guys?
Nope.
Okay. If there comes up something that you need, let me know. We will play with 8.2. What's today? Thursday. So we'll start with 8.2 Monday. 8.2 is really the same exact idea of this, except instead of distributing means, you're distributing proportions. So instead of dealing with average data, you're dealing with binomial data. So same idea, just it has a little bit of a different couple important differences to it, but it's the same basic idea. So feel free to start playing with that.
So we just need to have 8.1 done.
Yep.
By Monday.
Yep.
And then that gives us time to go back over. That's great. Thank you.
Sure. Okay, then
Cool.
I will see you guys Monday.
Thank you.
Have a wonderful
Bye.
day.
Bye.